So here we have an area under a curve. Clearly it's going to be the Riemann integral the way we have rectangles, partitioned rectangles. The difference is here that they no longer give further than sigma I equals 1 to n of 1 and sigma I equals 1 to n of I in the information booklet. So clearly they're not into having great big complex calculations, particularly as it ties up so many marks. So what often happens now is they actually give the already completed formula in terms of n of the area for n rectangles, and you work from there. So that's what we have. If we have n rectangles underneath this equation, underneath this graph, then there is the area in terms of n. So now if we had to find the exact area under there, we would find the limit as n tends to infinity, making the number of rectangles infinite, losing all the extras that we gain by having the rectangles. So if it's further given that f of 2 equals 6, so therefore that distance there is 6, determine the shaded area correct to 2 decimal places. Well, this is the rectangle minus the area under the curve, clearly. So the first thing we're going to have to do is find the area under the curve, which means finding the limit as n tends to infinity. Limit as n tends to infinity of that expression. Now, as n tends to infinity, that's constant, that's a constant, so they stay. But these two have n in the denominator, so they'll go to 0. So there is our area bounded by the curve from 0 to 2. Now, all we have to do is subtract that area from the area of the rectangle, which is 2 times 6, giving you 8 over 3 square units. Now we're into a few integration exercises. If we look at this first one, when we see a product, we always first ask, is that related to the derivative of the inside function? Well, the derivative of the inside function is 6x, so clearly that is related. So therefore we know we can do it by substitution. And the best substitution is let u equal 3x squared plus 7. That means du by dx equals 6x, which means du equals 6x dx. This is a pattern we always do. Now what we need to do is to replace dx with 6x dx. Well, there's the x we could take across there, so we have x dx. And to have 6x dx, we're going to have to put 1/6 on the outside. There we are. 1/6 of 6x still gives me x, but we now have our 6x dx, so we can write du instead of 6x dx, and we can write u instead of 3x squared plus 7. That's a very straightforward anti-differentiation, really. U to the 4 over 4 plus c, and we can substitute back. We need to substitute back because this is indefinite integral back to the x values. This is another product, but it's not substitution because we can see that that x is not related to the derivative of the inside function, which will end up being a constant. So we're going to have to do it by parts. Integral u dv equals uv minus integral v du. We have to choose which is going to be the dv, and which is going to be the u. Whatever's the dv, we're going to have to integrate. So I'm going to choose e to the 2x as the dv because it's not going to change much, because the integral of e to the x is e to the x. So all we have to do is worry about the 2. And choosing u as x, that means I'm going to differentiate the x and it goes away here. So first step, uv. So u is the x. So there it is, u equals the x. And the integral of v, the integral of, there's the e to the 2x is our dv. So its integral to give us v is e to the 2x again times a half to allow for the integral of the inside function minus. Now we're going to have v du. So we're going to have v again, which is e to the 2x times a half, e to the 2x times a half, and we'll put that on the outside. Du is 1. So now that's pretty straightforward now. This is half xe to the 2x minus, this is going to become e to the 2x over 2 again, times that gives you 1/4 e to the 2x, and plus your c. So this clearly is a partial fractions, because we can differentiate the bottom. The degree of the top is lower than the degree of the bottom. If it was equal to or higher, we'd have to do long division first. So we'll let this fraction with that factorized be equal to a over x plus 1 plus b over x minus 3. If there's an x minus 3 squared, we'd have to have b over x minus 3 plus c over x minus 3 squared. But it's quite straightforward, this. Find a common denominator and equate the exponents. I'm not worrying about the denominator. So therefore a into x minus 3 plus b into x plus 1. Now, to get rid of the b, I can substitute minus 1 for x, and that'll allow us to find a. So therefore that becomes minus 8 equals minus 4a, so a is 2. Now I can substitute 3 for x, because that'll get rid of the a. We'll have 4b, and we'll have 4, which means b is 1. So we can now go back and substitute 2 for a and 1 for b. Now these are straightforward lins now. Twice ln absolute value x plus 1, because we can't have log of a negative, plus ln absolute value x minus 3 plus c. If you don't put the absolute value, it may be fine. You may lose a single mark. I'm not sure how the marking goes.